Hey everybody, this is Larry. This is me doing the weekly premium challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Apparently I've also already solved this one, though it is not in cache, so we'll see. We have three largest binary search subtree. Given the root of a tree, binary tree, return the largest subtree that is a binary search tree. Okay, I think this is kind of relatively straightforward because binary search tree is by itself a recursive definition, right? Meaning that, well, actually they tell you this. The left subtree have value, right? So that means that if you kind of do it recursively, this node is a root of a binary search tree. If the left is a binary search tree, the right is a binary search tree, you build them up and in a way such that the invariant holds, right? The invariant where all the node or the big, I would say all the nodes in the left subtree is smaller than the current node, which is smaller than all the nodes on the right subtree, right? Of course, but from that, the largest node on the left side, if that's smaller than the current node, that's also good enough. So that's kind of the idea. And the largest means the number of nodes. Okay, so maybe for each one, we can do, let's say traverse, we have a node, and maybe we want to return three things, right? Maybe I should use name tuple. I always feel like I should use name tuple, but I always get lazy. But all right, so here, maybe we want to return largest value on the left, smallest value on the right, and then just the total number of nodes, right, in the subtree. And that's basically, I think, a general idea. If node is none, then what do we return? I don't know. Largest value is going to be infinity, negative infinity, and then 0. Something like that. I reserve the right to correct myself because I don't think through all the base case yet when I write them in the beginning. Just something that seems reasonable from experience. But yeah. And then now, oh yeah, and maybe actually one more, which is the Boolean for whether this subtree is BST, right? Okay, so then now let's just say if this is a leaf, then what happens? If this is a leaf, then we also return, of course, we return yeah, no dot value, no dot value. I think I'm doing this wrong. I'm messing this up. What I actually want is actually regardless of the left and the right. I mean, I think this is from something else in my mind. But what I actually want is just return the smallest value in this subtree. Sorry, friends. I think I confused myself a little bit, which happens from time to time. That's what we want to return, and then the left right is on the parent, right? So the parent does the stuff. Anyway, left right, the smallest value in the subtree, the largest value in the subtree, nodes in the subtree, which is 1 because this is a leaf, and true because it is a binary search subtree, right? Otherwise, then we go left is equal to traverse node dot left, right is equal to traverse node dot right, right? And maybe this is not quite correct anymore. Also, we're missing a value anyway. And if there is no node, then it's just true by default. But then the smallest value is maybe negative infinity, and the largest value. No, I mean this is fine. This I think I just used the wrong thing here. But yeah, the smallest value, so then this is always going to be true in a sentinel kind of way. That's what we want to use. Yeah, and then now, as we said, we want to make sure that left of the largest value is less than or equal to node dot value is less than or equal to the smallest value, right? So if this is the case, and of course left sub 3 Maybe I should have used the name tuple. Or even just wrap it in a class. All right, I mean, let's wrap it in a name tuple. Today, I have to. Today will be the day that I get a little bit more familiar with Python. It's been a while. I always look it up because it's not something that I write enough. But I think it's not that bad. But just like what's it called? Maybe R value for return value, which is a terrible name, by the way. Name tuple. You have an array, I think. Oh no. And then you have smallest, largest, count for, and then is BST maybe, right? So then now we can return value of this. I think that's right syntax. I don't know if this is right syntax, but I hope so. I'm just trying to figure out whether this does anything or does this crash. Okay, because I think if I had the wrong syntax, it would just be like, yo, you're being dumb, because it does traverse the entire thing. So I think this is okay for now. Anyway, yeah, and then we could put this here. Actually, not that bad, right? The name tuple syntax. I am just lazy, I think. Okay, so then now we can rewrite this as if left is BST and right is BST, then this one has a possibility of being BST, right? BST, right? So here, left sub largest is no dot value, right dot smallest, right? Then now, then this has a chance of being a BST. So maybe, yeah, force. Or maybe you can even just write this directly to what the, maybe just this directly into this, right? So then now we can return this in the future. And then the smallest, well, the smallest value is going to be left dot smallest, just by definition, right? Right dot largest. Count, it's going to be left dot count plus right dot count plus 1. Right, and then is BST, we just calculated this, so it's just that. I think that's mostly it. I think there's something that you can do. I mean, there are two ways to kind of take advantage of this to get the largest BST tree, which is, one is, it's what I'm going to do, but maybe I don't recommend, but the other way is just having another value in this return value to contain largest subtree or something like that. I think for me though, I'm going to use a non-global thing, right? Of yeah, oops, how did I? So if it's BST, then yeah, we want to, then this is, wait, do we return the node or the value? No, an int. Okay, so yeah, so then this is, you know, best is equal to max best of this, right? And then that should be good, right? Let's give it a spin. Okay, not good enough. What is 2? Is there a visualization? I think sometimes they have a visualization. Oh, there you go. Okay, so the answer is 2, but I put 8. Did I? Why did I put 8? Because 1, 2, 3. No, okay. So I guess this. It's less than, okay. I mean, their version of binary search tree does not have the equal sign, so it's just very easy fix, right? Run it. Okay, still wrong. Why is that? Why are you wrong? Why are you wrong? I mean, I guess it is the same entire tree, but why are you wrong? Oh. No, this is right. This has this. I thought maybe I forgot this, but it's clearly right there, right? So then why is this wrong? I mean, apparently this is true for all of them. Otherwise it wouldn't be. Yeah. That's weird though. 2, 2. So then left out largest is going to be 2, but then this is just false, right? So let's take a look whether that is true. Left out largest is 1. If I have something weird with this thing. Oh, I'm dumb. Yeah, because right for that tree, the right side is empty, but which is fine here. And I think this is roughly right, but this doesn't take account the emptiness. So the largest is either this or no dot value, right? Yeah. And then the smallest is the same thing. It's either this or no dot value. I mean, we set a sentinel for that reason, so that we can do this min and max this easily and not have to check out additional if statements. But then I just forgot about it. So yeah, forget about that case. All right, looks okay, right? So let's give a quick submit. Hopefully we didn't miss anything, and we did miss something, which is okay. Actually, I was thinking about this, but I was like, oh, I don't think we have to worry about that. Which is that if you have a root, then it is just going to be 0, because basically the TLDR is that because your root is the leaf, this returns, and so yeah, and then it just never updates this. I was like, I just forgot. That's why. I don't even know if this is queen, but this only happens when but a very silly mistake, of course, which has kind of been my middle name lately. Let's give a YOLO submit. Hopefully this time I'm right. Yes, so I could take a nap. All right. Yeah. What did I do? Oh, last time I didn't get a wrong answer, so I'm regressing. How did I do last time, though? I guess this is actually this is roughly the same idea. And even last time I used the name tuple. So I basically did the same thing, really. I don't know why this is a good default, but oh, I guess it's just that if this is false, it doesn't matter what these are, because so that's why I just have infinity there. But yeah, I didn't handle in the previous case. I didn't handle the leaf differently. I think I don't even need to. I've been making a habit to handle the leaves. I don't know how I feel about it, because apparently like in this case, it bit me in the butt. I didn't even need it really, but that's pretty awkward now though. But yeah, that is all I have with this one. This is the code. Hit all the buttons, the good ones, and that's it. Thanks for watching. This is going to be linear time, linear space. We have constant space and time for each node, so linear time, linear space. That's it. That's all I have with this one. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.